So we're going to start chapter 1, so this is section 1.1. This is about linear equations. Now we're going to kind of go away from the book and talk about systems of linear equations as well, which is just more than one. But for now we're just going to talk about linear equations. So the first question to ask is, what is a linear equation? So linear equation. So a linear equation, it just means that for any variable that you have, the highest power is 1. So the highest power on variables is 1. And we're not going to have anything like square roots or anything like that with our variables. The variable is just going to have all powers of 1. So some examples of linear equations. I could have p plus 2q minus 1 equals 8. That's a linear equation because all the powers, we don't write them, but all these powers that go right there, they're all 1. Another example of a linear equation. How about 2x plus 5 equals 10? It's a nice linear equation. Again, we don't write it. There's an understood 1 to be right there in that power. Something like this, 3 square root of x minus p equals 7. Now this is not a linear equation. Yeah, the p, which is one of our variables, has a power of 1. But because of this x, this is not a linear equation. So linear equation, all the powers have to be 1. That's what we want to think whenever we think linear equation. Now how do we solve linear equations? Remember, our goal is to get the variable by itself. So the goal is to get the variable by itself. That's our number one goal. Now how do you get the variable by itself? Well, we're going to kind of work backwards. So if you're adding and you want to get the variable by itself, you're going to subtract. If we're multiplying by something, we want to get rid of it, we're going to divide. So you always want to do the opposite to get the variable by itself. And also, if you think about the please excuse my dear Aunt Sally, we're going to work backwards. So instead of doing multiplication and division first, we'll do that last. So we're going to start with subtraction and stuff like that, and then work our way backwards. Now let's just kind of jump in here. So let's say that I have 3 equals 5x plus 2. And I want to solve this for x. I think we can all agree this is a linear equation. I got my equal sign and for equation, and I have my power of 1. The goal is to get x by itself. So ask yourself, why is x not by itself? Well, it's not by itself because of 2 reasons. It's not by itself because of this 5 and because of that 2. So what are we going to do? Well, we're going to get rid of the 2 first. Remember I said we work backwards with the please excuse my dear Aunt Sally, so addition and subtraction come first. So how do I get rid of adding a 2? Well, subtract a 2. And whatever you do to one side, you got to do to the other. So I'm going to subtract the 2. I'll get 5x equals 1. Now I'm going to kind of do something over here to the side. So a lot of people might be saying, well, why wouldn't you divide by 5 first? That's fine. If you want to divide by 5, that's completely fine. But you got to divide everything by 5. So if you want to divide by 5, by all means, you'll get 3/5 is x plus 2/5. Same equation, you just did a different step first. Now let me go back to the left over here. So I have 1 equals 5x. Why is x not by itself? Well, it's not by itself because of that 5. So how do you undo that multiplication by 5? We're going to divide by 5. So what do I get? I get 1/5 equals x. So what's my solution going to be? X equals 1/5. Now come back to the right hand side. Over here, why is x not by itself? Well, it's not by itself because this 2/5 is being added. So what we're going to do, we're going to subtract 2/5 from both sides, and I get x, and over here 3/5 minus 2/5, that's 1/5. So again, I get the same answer. Now you want to be careful. over here, I divided by 5 first, and that's completely fine. I would not recommend it because a lot of times what happens is people will forget to divide everything by 5, right? They'll just divide the 5x by 5 and not the 2. So maybe this left-hand side is probably the better way to do things. Okay, so we've done our first linear equation. Let's try another one. How about 3 times p plus 5 equals 8. Let me change that. Let me change that to a 9. Make it a little bit easier. 3 times p plus 5 equals 9. And I get some options. You got options as to what you do. Ask yourself why my variable is not by itself. Well, it's not by itself for a couple reasons. It's not by itself because we're adding 5 and we're also multiplying by this 3. So it's up to you what you do. You can either, and I'll do it both ways, you can distribute that 3, so I get 3p plus 15 equals 9. Now what would I do next? Probably subtract this 15. You could divide by 3. I'm not going to do that for the reason we just said. So let's see, 9 minus 15, what does that give me? Negative 6. And then why is p not by itself? Because of that 3, so I'm going to divide. So I get p is negative 2. Now that's the first way you could do this problem. Let me rewrite it over here. So I got 3 times p plus 5 equals 9. I don't have to distribute that 3. I could just go ahead and divide by 3 to begin with. So I'll get p plus 5 equals 3. Now why is p not by itself? Because of that 5, so I got to subtract 5 from both sides. P equals negative 2. Same answer, just two ways to do it. I don't really care which one you choose. Do the one that makes more sense to you. Okay, let's see. How about 2p minus 4 equals 4p plus 7. Now let me ask you this. Is this a linear equation? So do I have the power of 1 for all of my variables? And we do. You can see that the p here and here has the power of 1. So this is a linear equation. Now why is this one more difficult to solve than all the ones that we've done? Well, the problem is the p is on both sides. So whenever you see this, so whenever the variable is on both sides, so if the variable is on both sides, you want to move to one side. So since I have my variable on both sides, I'm going to move one of them to the other side. It doesn't matter which one you move. Let's say I move this 2p. If I move that 2p, well, I'm just left with a negative 4 on the left. Then what do I have over here? Well, I had 4 p's, I subtracted 2 of them, so I'm down to 2. So I have 2p plus 7. And now this is an equation we've done before. You're going to subtract your 7 from both sides. So negative 4 minus 7, what is that? That gives me negative 11. And lastly, we need to divide by 2. So I'll get p over here and negative 11 halves, or negative 5.5, whatever you want to call it. And there's my p. Now again, if you have your variable on both sides, move it so that it's just on one side, and then go from there. Right, I do want to do one more example of this. So let's say I have something like 3 over x plus 1 equals 2 over x minus 4. Doesn't look like it's a linear equation right off, but I promise you it is. The powers on x are all 1. So how do we solve this? Well, we can't just go adding and subtracting and expect it to fall out like we did in the beginning. The problem here is that x is in the denominator. So whenever your variable is in the denominator, get it out. So multiply on both sides by the denominator to get it out. Now the nice part about this is that I can cross multiply. So you've probably seen cross multiplying before. I'm going to multiply to get 2x plus 1. I'm going to be very careful with parentheses here. And then my other side, 3x minus 4. So to get x out of the denominator, I multiplied. Here it was cross multiplication. Let's see, now what can I do? I'll probably distribute. So I'll have 2x plus 2 equals 3x minus 12. Now we're in that situation where x is on both sides. So what do you do when your variable's on both sides? You're going to move one of them to the other side. Doesn't matter which one you move. I'm going to move the 2x over. So I'll get 2 is x minus 12. Now why is x not by itself? Because of that 12, so we're going to do the opposite. So I get x is 14. So there's my answer. So just to kind of recap here, if you have your variable in the denominator, what you want to do is you want to multiply to get it out. So I cross multiplied and I got my variable out of the denominator. If your variable's on both sides, so that's kind of this case here, move your variable to be one side and then go back to what you were doing before.